Hello and welcome. Today we're going to be doing Leetcode 1099, two sum less than k. This is a pretty interesting problem in my opinion. Oh, where is my pen? Let's do blue. Two sum less than k. Highly recommend that you do Leetcode 1, which is two sum, because this kind of, in a way, at least with the brute force, works very similarly, but the optimal solution might be a little different than what the two sum solution might be, which is using a hash map. This one is a little different. But with that being said, let's go ahead and try to take a stab at this. So you are giving an array of nums, integer of k, return the maximum sum such that there exists I less than j with nums of I and nums of j equal to the sum, and the sum is being less than k. If not, I and j exist satisfying this equation, return minus 1. So if we never find any two summations like I plus j being less than k, we return -1. So with that being said, let's go ahead and try to jump into the explanation of the brute force. So the first thing you need to do, and here let me just keep on using this example, is using the I pointer, and we get the j pointer from a doubly nested for loop. And what we're going to do is we're going to check every single possible combination that adds up to be less than k. So as we're going down the road, we have 4i in range, length of nums, while for j in range of I plus 1, because we got to store right in front of I. Make sure we satisfy this condition that I is less than always j, and length of nums. We can compute the current sum just to make our life easier. Nums of I plus nums of j. So this is j. So if current sum, if I can spell sum less than k, then we would compute that into being our result variable, which, by the way, let me change colors here just to get your attention for a minute. The result, which should be initialized, I'll just initialize it here. The result is equal to float negative infinity, or it could be -1, but given that the problem did not state that we might be getting negative numbers, I'm going to assume we might in some other test cases. So let's just go ahead and give it the worst case scenario. And if the current sum, going back to this core logic, current sum is less than k, we would like to compute the maximum sum that is less than k. So as close as we can get to k, right here. So we're going to do result is equal to the max between the result and current sum. And that, oh, sorry. Actually, now that I think about it, we should return -1, because the question stated that if we run into a situation where we cannot get anything that is less than k, we should return -1. So that being said, this is pretty much the solution. It's a doubly nested for loop, and you would get the solution. It's the brute force approach. But let's go ahead and move to the other page and talk about the more optimal solution. So in the more optimal solution, you are going to be using a two-pointer technique. And more specifically, the conversion type. where we have left starting here and then right, and then they keep on coming and trying to meet in the middle. Also, it is good to just sort the array because, again, the array is not also sorted. That way it makes our life easier in determining where can we find the satisfying condition of having the current sum being less than k. So first you need to sort, and then two, iterate. Through the array. I'm going to use an example here. I'm going to just borrow one of these. I'm going to make one. So we got 10. Let's do like 30 and 20. And k is equal to let's go with 50 because the example had it at 15, -5, but I want to use an example that can utilize this problem. And we're going to start here with, we got a left loop and you get the right loop. And you're going to say, boom, boom. Let me just go do this. While left is less than the right, and we're going to compute the current sum as we always do, just like in the brute force. Nums of left plus nums of right. Oh, and also we would sort this array, so technically this will go like that: 10, 20, and 30. So, here are pointers. Cool. So, going back to this core logic again. If current sum is less than the target, or sorry, k, then we would like to, again, compute that into the result variable, which is again equal to -1. So the result will have the maximum value that is closest to k, but not equal to k, smaller than k. So current sum and the result itself. Else, we have reached a point where we are greater than k, and we want to decrement. Oh, sorry. I should add. We have to also increment the left pointer here. So we're going to come here, and wait till the left pointer to go up. Else, we would like to decrement the right pointer, and then once the loop ends, we would like to return result. So we can do a dry run right here. It's very important that you do this in your interview. As soon as you create the algorithm, just do a quick dry run. So as we start, as long as left and right are left is less than right, we're good. We are going to compute, hey, 10 plus 30 is equal to 40, and that is going to be satisfied here. And now res is equal to 40. And we're going to increment the left pointer. So now left is here. Now 20 plus 30 is equal to 50. And that is greater than, and it's not less than k. So here, actually, for this case, sorry, I'm going to cheat here for a minute. I'm going to say, what was it, 40? Let's do 45. So right here, at this point, again, we're going back to this example. we get 50. 50 is greater than, that's our else condition over here. And in this case, we would tell the right pointer to decrement, and at this point, the left and the right pointer would meet, which breaks this loop, and we would return the result. But let's just say, for an example, we had, I'm gonna burn some of this stuff. Sorry, it's a little bit late where I'm at, so that's why I'm a little slow, so I apologize. We had a 10, 20, 30, 45, let's do 60. And K is equal to, let's do 40. So again, we would start in left and right. 60 plus 10, that's 70. So we're gonna come down here. That'll be 55. Again, we're gonna keep going down. And we found our 30, 40. Technically, this would be still, let's do, sorry, I'm gonna cheat again. I'm gonna say, this is 43. So we got 10 and 40. So at this point, our result will compute this value, and it'll be 40 since it's less than 43. And we're gonna increment our left pointer. So it'll be right here. And that's gonna be 50. 50 is greater than, and it's gonna greater than the K. And we're gonna tell the right pointer to decrement, and that's gonna break the loop. So our result will be 40, and 40 will be what is returned. So hopefully that makes sense. I'm gonna go ahead and jump right into the Leetcode and code this up, and then hopefully run it and make sure that I'm not lying. So we're gonna transition right now to the into Leetcode. Thank you. All right, we're back at the we're back at the Leetcode. So we're gonna try to code the solution up. First, let's go ahead and sort the input array. So nums.sort, just in case if we are giving a non-sorted array and the question doesn't specify whether we would be getting a sorted array. So we're just gonna assume worst case scenario that we wouldn't. And we would like to declare our result and initialize it to -1. Declare our left and right pointer to be 0 and length of nums -1. And then going through the while loop of left being smaller than the right. Calculating the current sum, nums of left plus nums of right. If current sum is smaller than K, so we found a base case that meets the condition of the question. And we would like to store this into our result as long as it is greater in terms of being a bigger value, because we're trying to get the maximum. So result will be max result, and what is it? Current sum. And we would increment our left pointer. Else decrement our right pointer because we found something larger than the current sum, than K. So in that case, we would like to return the result. So let's go ahead and run this. Pretty efficient, and go ahead and submit it. And I've never seen that in a long time where my solution gets in the far left. That's pretty cool. But yeah, the time complexity is n log n. The reason why is because we are embedding this sorting functionality, built-in functionality that does n log n time. And we have a while loop. So technically the while loop, the n of this guy comes from this while loop because we're iterating through the array, and log n is the time that it takes for the sorting algorithm to kick in. So that's why it's n log n. Memory is O of 1. Yep. And yeah, hopefully this solution was helpful. First, going through the brute force seems to be the most natural cause of plan, and then switching into a more optimized solution would definitely be the way to go. And with it in doubt, when it comes to this kind of problems, two-pointer conversion is the way to go. So thank you for watching. I hope this was pretty helpful. I hope you have a good